Hi, everyone. So this next unit is on our unit on trigonometry. And so our very first section is a section called special right triangles. So special right triangles are basically right triangles that have special properties. There are two types of special right triangles. There are something called 45, 45, 90 and 30, 60, 90. They're called this because those are just like the types of angles that they have. So if you have a triangle, what we're going to do first is a triangle that have angles that are 45 degrees, and 90 degrees. So rather than me just tell you what the relationship between the sides and the diagonal are, or the sides and the hypotenuse, I should say, we're going to derive it using this square here, and we're going to use Pythagorean theorem. So this is a square, as you can see. Square has all the sides that are the same. And remember, it has right angles in all the corners. The diagonals cut the corners in half. So remember that in every square you have 45-degree angles when you have the diagonals drawn in. So a square with one diagonal like this one has two 45, 45, 90 triangles. See, this is one, there's the other one. Notice that since there are two 45-degree angles, that each triangle is isosceles. So 45, 45, 90 is isosceles. I'm going to call the sides that are the same, I'm going to call those S for the sake of this, and I'm going to call the diagonal D. So what I'm going to do is I'm going to take S, S, and D, and I'm going to plug it into the Pythagorean theorem and simplify best I can. We're going to solve for D, and you'll see what happens. So I'm going to have S squared plus S squared equals D squared. And if I were to solve for D here, I'm going to combine S squared and S squared to get 2S squared. And now to solve for D, I'm going to take the square root of both sides. So I have D equals. Now let's see, how can we simplify this? 2 is not a perfect square, but S squared is. So the square root of S squared is S, so I can take that out. And then I have the square root of 2. So I've now successfully solved for D. And so D, the diagonal or the hypotenuse in this triangle, is equal to the side times radical 2. That's what the relationship is here. So if you take a look at this box, it should read in a 45, 45, 90 triangle, the hypotenuse is radical 2 times as long as a leg. And the legs are the same, so that's why it says a leg, because it doesn't matter which one. So these are equal. This is a leg. This is a leg. This is hypotenuse. I like to call the leg X and the hypotenuse X radical 2. So basically, if you're going from leg to hypotenuse, that's the easiest kind, you just multiply by radical 2. If you're going from hypotenuse to leg, you would divide by radical 2. So leg to hypotenuse, multiply by radical 2. Hypotenuse to leg, divide by radical 2. It's pretty simple. Now, the only thing that's not simple is working with radicals, which that's why last week I had you guys do those ed puzzles on simplifying radicals and multiplying and dividing radicals. So I'm going to do these notes as if you have watched those and had a good understanding of them. If you have not done those ed puzzles, you might want to go back and watch those first, because I'm not going to go through and teach how to do all that in this lesson. I mean, I'll remind you of some things, but normally I do a full-on lesson on it. That's what the ed puzzles were for. So let's get started with this first example. So when you're doing special right triangles, first you want to think about what kind of special right triangle is it? Well, I've only shown you this kind, 45, 45, 90. And then you want to think about, what am I given? Am I given a leg or a hypotenuse? This is a leg. So the legs are the same. So this is also 4. To go from leg to hypotenuse, you multiply by radical 2. So leg to hypotenuse, we multiply by radical 2. So there's really nothing much to this here. We're just going to do 4 times radical 2, which is 4 radical 2. That can't be simplified at all. You just kind of stick them next to each other. That's the answer for the first one. Pretty easy. Okay, let's take a look at number 2. So again, it's a 45, 45, 90. This is the hypotenuse. I need a leg. So to go from hypotenuse to leg, we're going to divide by radical 2. So 3 radical 2 divided by radical 2. See how I have radical 2 over radical 2? Those cancel because that's the same as 1. And I'm just left with 3. So that means this is 3, x is 3, and this side's 3 because these are equal. Okay, a couple more examples. Okay, something like this. This is the hypotenuse, and I want a leg. So again, just like the last example, from hypotenuse to leg, I have to divide by radical 2. Now, notice this time, nothing cancels. So I have a radical in the denominator. In the Edpuzzles from last week, you learned that you cannot leave a radical in the denominator. If you end up with one in the denominator because you're dividing, you have to do what's called rationalize the denominator. To rationalize the denominator, you multiply the fraction by whatever radical's in the bottom, and you multiply that by over itself, like radical 2 over radical 2. And the reason why we do this is radical 2 over radical 2 is 1. So you can multiply anything by 1, and it's not really changing the value of it. It's just making it so you'll see we don't have a radical in the denominator. So then you multiply across. So then I have 18 radical 2. And then radical 2 times radical 2 is 2. And so if you don't understand why that is, you off to the side. Radical 2 times radical 2 is radical 4. And then what is the square root of 4? 2. So it's just a plain 2. So I have 18 radical 2 over 2. The 18 and the 2 can reduce, and so I have 9 radical 2 as my final answer for x. So that's the leg. And they're both 9 radical 2. Number 4. This time I'm given a leg to hypotenuse. You multiply by radical 2. So I have 3 radical 2 over 2, and I'm multiplying by radical 2. And it's over 1. It's not radical 2 over radical 2. I'm not rationalizing here. I'm just multiplying by a plain radical 2. And so now we're going to multiply the top, multiply the bottom. So 3 radical 2 times radical 2. Radical 2 times radical 2 is just 2. So that's really 3 times 2 over 2. And so that's 6 over 2, which is 3. So that would be the hypotenuse is 3. And then y, these are equal. So this is just 3 radical 2 over 2. Because the legs are the same in a 45, 45, 90. So that's pretty much kind of like one of each type that you'll see for 45, 45, 90. The next type is called a 30, 60, 90. 30, 60, 90 can get a little bit more complicated, and the reason why is because it's not isosceles. So there's 3 different sides that we find, not just 2. So there's 3 relationships that we talk about. So I am going to derive this one as well. We're going to use this equilateral triangle. Remember how equilateral triangles, the angles are 60. So these are both 60. This is 30 and this is 30 because this is an altitude, which also ends up being a perpendicular bisector. So these are equal. And so, well, let's see, I'm going to get rid of that. We don't actually really need that right now. So I'm going to focus on like this side here. When you have a 30, 60, 90 triangle, your shorter leg is like kind of the key to the puzzle is what I like to call it. Like if you don't have the short leg, you better find the short leg first. So you always, if you're not given the short leg, find that first, and then it's super easy to find the last one. So remember that the shorter leg is opposite the smaller angle in a triangle. So that means that this right here is the short leg. I'm going to call it S. Now, if you think about it, if both of these were the same, right? And this is an equilateral triangle, so this whole side would be the same as this whole side would be the same as this whole side. So I could call this side and this side 2S, right? 2 times the short leg. So in a 30, 60, 90, the hypotenuse is double the short leg, which makes sense based off of this, right? And then the long leg is the one that's a little trickier. So I'm going to call this long leg, I'm going to just call it A, so it doesn't look like a number. I was going to call it L, but I'm going to call it A. So now I'm going to focus in on this triangle, just one of them. This I was just putting there just to show you that, you know, it's the same. I'm going to focus on that red triangle. I'm going to plug S, A, and 2S into Pythagorean theorem. So here we go. So we have A squared plus S squared equals 2S squared. 2S squared is going to be 2 squared is 4, S squared is S squared. So now I have A squared plus S squared equals 4S squared. Now I'm going to subtract S squared from both sides because I'm solving for A squared here. So A squared equals 3S squared. And then lastly, I'm going to take the square root of both sides. So I have A is equal to. So the square root of S squared is S. The square root of 3, it's not a perfect square, so it's just going to be this, S radical 3. So what that means is the long leg, or in this case A, is equal to the short leg times radical 3. So this is S radical 3. So if this was 5, this would be 10. This would be 5 radical 3. So there's a little bit more to it than that. I'll show you a bunch of examples, but that's the basics of it. So if you see this box here in a 30, 60, 90 triangle, let's see which one goes first here. The hypotenuse is twice as long as the short leg, and the long leg is radical 3 times as long as the short leg. So when we're doing 30, 60, 90, there's always a short leg. I like to abbreviate that SL. It's across from the 30-degree angle. Then there's the long leg, LL. That's across from the 60-degree angle. And then the hypotenuse, of course. So like I said, the short leg is the key to the puzzle. So I'm going to call that X for this picture. I'm going to call the hypotenuse 2X. So if you're going to go from short leg to hypotenuse, you double it. And then from short leg to long leg, you multiply by radical 3, like how I just showed you when we did Pythagorean theorem. So that's a relationship here. So I'm going to do one of each example. Again, just like on the other one, well, actually, perhaps more important with the 30, 60, 90, you want to look at what you're given and think about, am I given the short leg, the long leg, or the hypotenuse? If you're given anything other than the short leg, you need to find the short leg first. Really important. So this one, I am given the short leg first. So this is the short leg, this is the long leg, this is the hypotenuse. So short leg to hypotenuse, super easy. You just multiply by 2. So 1/2 times 2 is 1. So X is 1 here. Short leg to long leg, we multiply by radical 3. So this is just going to be 1/2 times radical 3. Clean that up a bit. It's just better just to write radical 3 over 2. That would be your long leg. So that's your Y. So see how if you're given the short leg, it's pretty easy. You're just multiplying to find the hypotenuse and the long leg. Number 6, we're given the hypotenuse. We need to find the short leg and the long leg. Again, remember, find the short leg first by dividing by 2, because remember the hypotenuse is double the short leg. So X here is just 11 over 2. And you can write it as 5.5 if you want, but usually with radicals and special right triangles, we like leave it in not decimal, fraction form. Okay, and now that I have the short leg, to get to the long leg, I'm just going to multiply by radical 3. So it's going to be 11 radical 3 over 2. That's your Y here. Okay, so that's an example given the hypotenuse. Something like example 7, I guess you could say is the hardest, but even then it's really not that difficult. So see how I'm given the long leg. I need to find the short leg first. And then once I get the short leg, I can easily find the hypotenuse. So to go from long leg to short leg, we are dividing by radical 3. So let's start there. So 9 divided by radical 3. Remember, you cannot leave a radical in the denominator, so we are rationalizing. So then we multiply across. So 9 times radical 3 is 9 radical 3. Radical 3 times radical 3 is 3, because again, off to the side, radical 3 times radical 3 is really radical 9, and the square root of 9 is 3. So it's just a plain 3. Any radical times itself is just that number, the radicand that's underneath. So now I can reduce 9 over 3 is 3. So the short leg is 3 radical 3. That's my x. Okay, so now to go from short leg to hypotenuse, remember we just multiply by 2. So I'll do that down here. So 3 radical 3 times 2, you would just multiply the 2 coefficient, well, the 2 and the coefficient, so that's going to be 6 radical 3. So that's your y. So y is 6 radical 3, x is 3 radical 3. And so that's it. So just remember when you're doing these, the practice you're going to do is going to be mixed up 45, 45, 90s and 30, 60, 90s. First determine which type it is, then determine which part you're given, and then based on what I just talked about, you do what you need to do to get the rest of them. So try the problems. I know this is a tricky topic to learn from home. Feel free to come to ACLAB today and I can help you go through some. We're going to do more of these tomorrow. So give them a try and I will see you guys tomorrow. Have a great day.